In this video, we are going to use the trapezoidal rule to approximate the area under the given function on the given interval. Here is the curve of sin x from 0 to pi starting from the origin. We need to divide this interval into 4 sub-intervals. So let us find the width of each interval, which is b minus a over n. N is 4 over here. So we got the width of each sub-interval as pi over 4. We draw the 4 trapezoids on these 4 intervals and we can see that the top side of these trapezoids run very close to the curve. That means it is going to give us a better approximation of the area. When we use the Riemann sum to find the area, we use rectangles. When we use rectangles, either using the left point or using the right end point, those rectangles give us either the lower estimate or the upper estimate. For example, for this part, if we use the left end point, then this rectangle will give us a underestimate, or if we use the right end point, then the rectangle would be like this and this will give us overestimate. So using the left or right Riemann sum gives us either the lower estimation or the overestimation, which is not very close to the actual area. But trapezoidal rule is going to give us a better approximation than the Riemann sum. Here is the formula which we are going to use to find the area of each trapezoid. This is the same formula which we learned in geometry classes. So area of each trapezoid is given as the sum of parallel sides, sum of these parallel sides times height or width all over 2. Here the sides B1 and B2 is given by the y value at those endpoints. To get the y value, we just plug in those endpoints into the given function fx equals sin x. So let us find the area of first trapezoid. B1 is 0 here, so 0 plus other parallel side B2 is the y value at pi over 4. So we just plug in pi over 4 into the given function. This is sine of pi over 4 times width. Width of each interval is pi over 4, all divided by 2. Now we plug in the value of sine pi over 4, which is square root 2 over 2 all over 2 times pi over 4, which becomes this 2 in the denominator can be written as 2 over 1, which get flipped later on and it becomes square root 2 over 2 times 1 over 2 times pi over. This is the area of first trapezoid. The area of second trapezoid would be the sum of parallel sides, which is sine pi over 4 plus sine pi over 2 all divided by 2 times the width of sub-interval pi over 4. The parallel sides are actually the y value at each endpoints. We write the values of sine pi over 4, which is square root 2 over 2 plus sine pi over 2 is 1 all over 2. When we simplify it times this 2 in the denominator get flipped and it's again times 1 over 2. Then area of third trapezoid would be, this is the third trapezoid. So here the endpoints are pi over 2 and 3 pi over 4. So the sum of parallel sides would be the y values at these endpoints. So sine of pi over 2 plus sine of 3 pi over. Area of fourth trapezoid would be sine 3 pi over 4 plus sine pi all over 2 times width. When we simplify it, we are going to get the same thing. Next, we add the area of all the 4 trapezoids to get the final approximation. Area under the curve is written as, because this definite integral represents the area under the curve on the interval 0 to pi. The sum of all trapezoids, we see that pi over 4 is common to all the 4 parts, so it can be taken out. All of these terms have the same denominator. This area gets simplified too. So this is the area under the curve on the given interval. There is another shorter way to approximate the area using trapezoidal rule. We observe that when we are finding the area of each trapezoid separately and then adding them all at the end, each parallel side get repeated. Here sine pi over 4 and sine pi over 4. These two sides get repeated. Then sine pi over 2, sine pi over 2 here get repeated. Sine 3 pi over 4 and sine 3 pi over 4 get repeated. except the very first side and the last side. When we combine all the four areas, a new area formula comes into consideration. Since the width of each interval is common, is same for all the subintervals. So here it is the width of each subinterval, and this is the very first side, this is the very last side, and these are the intermediate sides. Because all these get repeated twice, so we put 2 in front of them. Now let us see if we get the same answer using this formula. So area is pi minus 0, b is pi, a is 0 over 2 times the number of subinterval is 4, f of x naught. The very first endpoint was 0. The second endpoint was pi over 4. Next we plug in these values into the given function into sine x. So it's sine of 0 plus 2 sine of pi over 4. So we can see that we got the same area as we got using the earlier way when we found the area of each trapezoid separately and then add them all at the end. And this way is a little shorter, but keep in mind we can use this way only if the width of each interval is same, when the given interval is subdivided into equal intervals.